All right, well, good morning, everyone. Welcome back to another exciting day in mathematics. Whoop, whoop. Warm-up 95 is on the screen. That shouldn't take you long. I'm going to give you a head start, but I am going to go through a couple of these just to make sure that we got each portion. And, yeah, I'm recording this session, by the way. All right, so with that said, here goes number one. Number one says right in slope-intercept form. What does that mean? Remind your neighbor. Okay, good. It means to solve for y. So that means we need to leave y by itself. So I subtract 12 from each side. We're left with negative 3y equals negative 6x minus 12. And then we divide by negative 3 both sides. So we end up with y equals 2x, and it's a negative 2x, minus 6. So why is this slope-intercept form? Because it looks like this. Y equals mx plus b, where the m stands for slope, and the plus b stands for the y-intercept. Why do we need that? Because we need to know how to graph that, because now we're going to get into more of the transformations using all the different types of equations that we've used so far. So if I was to graph this one in slope-intercept form, where do we start, everyone? At negative 6. So I go 1, 2, 3, 4, 5, 6. Just bringing this back because we do need it, and we've covered this before. And what is the slope? Slope is negative 2, and fraction form is negative 2 over 1. What does that mean, Mr. Q? That means 2 steps down and 1 to the right. So I go 1, 2, 1 to the right, plot your point, do it again. 1, 2, 1 to the right, plot your point, do it again. 1, 2, 1 to the right, plot your point, graph your line. So at that point, I graph my line. Looks something like this. Woo-wee. Good review, yes? Yes, Mr. Q. All right, good. Let me zoom out. Next, number 2. It said graph equals f of x equals x cubed. So what does that look like? For those of you that forgot, it looks like this. Negative 1, negative 1, negative 2, negative 8, 1, 2, 3, 4, 5, 6, 7, 8, 0, 0, 1, 1, and 2 8s. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, which is over here. All right, there it is. However, look up. They give us this transformation. Tell your neighbor the vertex of the new transformation. What is that vertex? Instead of 0, 0, where shall we move the whole thing? Tell your neighbor, then Jacob squared is going to enlighten us. Where are we moving that whole thing to? Ah. Where are we moving the whole thing? Jacob squared. 5, 2, that is correct. And where do we get that from? H and K. What is H? 5. What is K? 2. So instead of being at 0, 0, we move it to 1, 2, 3, 4, 5, 2 up. So this whole thing with all its points is going to move over here. Hands if you got something like that. All right, good. Number 3, factor by grouping. And I'm going over this a little bit more expeditiously because we have to get to the lesson, and today we're moving on. Step 1, standard form. Is this in standard form? No. X squared plus 4x plus 2x plus 8. Now it's in standard form. What's the second thing we check for? Martin. GCF, is there GCF anyone? Nope. So now we group. We group the first two, second two. GCF is x, x plus 4. GCF for the second two is 2. We're left with x plus 4, my factors. X plus 4, x plus 2. Hands if you got that by yourself. Okay, good. Go to number 3B. Standard form, yes. GCF, no. 2 times 6 is 12. 7 goes underneath. Factors of 12 that add up to 7. Courtney Jean says 4 and 3. That is correct. So I bring down my first term, bring down my last term, and then instead of 7, I'm going to write 4 and 3. 4x, 3x. Group. GCF here is 2x. We're left with x plus 4. Oh, my bad. Plus 2. Sorry. And then GCF here is 3. We're left with x plus 2. Therefore, x plus 2, 2x plus 3. And if you got that by yourself, all right. By the way, you guys need to continue practicing this, guys, because we're about to need all of that. Let's go to synthetic division. Like I said, for the sake of time, here it goes. Look up to the screen. Is it in standard form? Yes. Anything missing? No. This one same. So then we set this equal to 0, solve. So we're going to start with 2. Coefficient is 3, 16, 5. Bring down the 3. 2 times 3 is 6. Combine 22. 2 times 22 is 44. Combine, that's 49. That's my remainder. So since we started with a square, that means this is 3x plus 22. We have a remainder of 49 over x minus 2. Woo-wee. Are we doing good? You're like, Q, just give us another pop party. Oh, by the way, the third quarter's ending already. Let's go. Oh, yeah, we got this. Let's go with the last one. Solve the system by substitution. What is the first thing we do when we have two equations like this? We check to see if what? Tell your neighbor, check to see if what? Jacob squared, pass someone. Brandon Doherty, what do we check to see? One of the equations is what? Equal, yes. They have to be equal because it's an equation. But if one equation solved for one variable, look at them. Is this one solved for one variable? No. How about this one? No. So we need to solve one. Which one, Jay? Top or bottom? All right. So for which variable do you want to solve for, x or y? So that means we leave x by itself, subtract y, subtract y. So this equation now is x equals 3 minus y. So what does that mean, Mr. Q? That on the second equation, instead of writing x, what are we going to write, everyone? 3 minus y. So we write 3 minus y. Then we bring down the negative y equals to 1. Combine like terms. What is negative y, negative y? Negative 2y. Bring down the 3 equals to 1. And let's solve. Minus 3 minus 3. That leaves us with negative 2y equals negative 2. Divide by negative 2. Y equals 1. And now we need to solve for x because our solution, we already have the y value. We need an x value. I'm going to use this equation, the one in red. X equals 3 minus y. What was y we said? Y was 1. Therefore, x equals to 2. Remind your neighbor what this solution means. What does that solution mean? Jay, pass someone. What does that solution mean? Brandon? Felix, what does this solution mean? Starts with the letter I. Yes, intersection of the equations or the graphs. Keep that in mind because today we're going to move on to systems and it's going to be fun. All right, copy the agenda, please. Warm up number 95, systems of equations. Home plate tonight is only 6 systems. 6 systems problems only. However, let me take a quick pause right here, and I'm going to ask you guys to get your cell phones out. Oh, yeah. And it's being recorded. So get your cell phones out, go to Canvas, Our Class, go to Grades, screenshot, and get that signed, please. Now, why do we need that? Because I'm closing grades Thursday in the afternoon because I'm going to turn in grades on Friday because the third quarter is ending, and I'm not taking any work home on the weekends. How about them apples? Ooh-wee. Let's go. We good? Yes? All right. Copy the code for tonight's home plate. T2YIJ. 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 All right, and some of you, as you are on Canvas, you're navigating, you're looking at your stuff. Once again, turn in late assignments. Missing assignments, you're still on time. Turn in what you need to turn in. Bah. Tell you never what I just said. Aside from bah. Wow. All right, so there's the home plate for tonight. Oh, yes, let's go. All right, get a Cornell note ready, please. Going to go super fast, so make sure you stay focused. You do need a fair model today. I'll give you some time to set that up. Copy and some of you are like, can you just give us the pop parquet now? Jay. How are you guys doing with your grades for your other classes? Good? Yeah, let's finish strong, guys. Third quarter. So, can't believe we're only like 2 months away from summer, right? Or let me rephrase that. We're almost 2 months and a little bit more away from 120-degree weather. Bless you. 120 degrees. Woo! Bring it. Like we're going to be running outside or something. Here we go. So, solve the system by substitution. Look up to the screen. Let me zoom in. This is very similar to what we've been doing on the warm-ups. Here we go. Look at this equation. What is the first thing we check for before solving? Tell your neighbor. We just covered this on the warm-up. Let's see if you remember. What is the first thing we check for? All right, Rylan, pass someone. What is the first thing we check for? Oh, Brandon Felix. Jacob squared. What do you think? Jacob, what do you think? First thing we check for is that one equation is solved for one variable. Look at it. Do we have one equation solved for one variable? No. Which would be the easiest to solve, the top one or the bottom one? So therefore, we're going to leave y by itself, so we add x. Do that with me as well. I'm going to use red for this part. So that leaves me with a new equation, which is, what's on the left side? y, and on the right side, x plus 1. So once we do that, look up. Let's put the wiggles on this. We're no longer going to use the original one. We're just going to focus on this one and that one. So, since we're using the substitution method, that means we're going to substitute this one into the first equation. So, where do we substitute this? Anywhere we see a what? A y, we're going to substitute x plus 1. So, to keep us organized, look up. Use an arrow. Bring this one down. And we're going to write blank minus 6x equals x squared plus 5. And instead of the y, we're going to substitute x plus 1. All right. Now that we have one equation, look at it. Is it one equation? Yes. But what kind of equation? It's a quadratic equation. When we solve quadratic equations, we need it to equal what? 0. Bless you. 0, infinity. Look up. It has to be equal to what? 0. So that means I need to leave one side by itself. So I'm going to do this. I'm going to get rid of all of this. But before I do, let me combine stuff. What is x minus 6x? That is negative 5x. Bring down the plus 1 equals to x squared plus 5. And now we're going to move everything to the other side to leave this side with a 0. So we add 5x and minus 1. Add 5x minus 1 to both sides. So now we end up with 0 equals x squared. 5x, is there another x to combine? No. 5x. And what is 5 minus 1? 5 minus 1 is 4. Fairly simple so far, yes? Okay. All right. Next, look at it. How do we solve this equation? Your brain should be able to take up from here. Tell your neighbor what to do from here. What do we do from there? One word. What do we do from there? One word. Noah. Brandon Doherty. Very good. Factor. That is correct. How do we factor this? What goes on top? 4. What goes underneath? 5. Factors of 4 that add up to 5. Everyone. 1 and 4. That is correct. 1 times 4 is 4. 1 plus 4 is 5. So my factors are x plus 1, x plus 4, and all that equal to 0. So far, so good? Tell your neighbor what to do from there to continue solving. What do we do next? All right, let's bring it to this side. Kimberly, what do we do next? Yeah, set each one equal to 0. X plus 1 equal to 0, and x plus 4 equal to 0. And then we solve. Let's see. Minus 1 minus 1, x equals negative 1. Minus 4 minus 4, x equals negative 4. All right. Let me pause the tunes. We're done solving this quadratic equation, but before it was a quadratic equation, look up. Look up. Where did we get it from? From combining these two, right? And what was that? What did we call that? A system. That means for that system, look up, we need solutions. One solution or two solutions. In this case, look up, how many x's do we have? 2. So check this out. Underneath this one, I want you to open a parentheses and write the value of negative 1 for x. Underneath this one, write the value of negative 4 for x. So what does that mean, Mr. Q? That I need a y value now for each of these. Where do we get that from, Mr. Q? Well, you use one of the original equations, either the top one or the bottom one, to substitute those values. Which one do you want to use? The top one or the bottom one? Which one, Martin? Bottom one, he says. So take the red one. I'm going to use red ink. Bring this down. We're going to write it twice. Y equals x plus 1. Y equals x plus 1. Why did we write it twice? Because we're going to substitute first for 1, negative 1 for the x. And then for the second one, we're going to substitute negative 4 for the x. So therefore, we end up with y equals blank plus 1. That blank is a negative 1. So what is my y value when x is negative 1? That is 0. So that goes right there. Do the same thing for the second one. Y equals blank plus 1, and that blank was negative 4. So what is y now? Y is equal to negative 3. And that goes right there. So now we have our solutions. Now check this out. We have how many solutions? 2 of them. 1, 2. But where did that come from? Once again, let me zoom out. Where did that come from? From the system. So remind your neighbor, when we come up with a solution of a system, what does that mean? Tell your neighbor, please, what does that mean? What does that mean? Clarissa, what does that mean? Earlier, Brandon Felix enlightened us with a warm-up, and he let us know. That is correct. Write it in there. Intersection of both graphs. They're going to intersect at those points. So, on the right side, I want you to make a coordinate plane from negative 10 to 10. I'll give you some time. Hurry up, please. All right, as you're setting up, here goes the entire process one more time for substitution. We were given a system of equations, a quadratic and a linear, and they asked us to solve using substitution method. What do we need to check to see if one of the equations would solve for one variable? They weren't. So we solved the bottom one for y. We added x to each side, and we ended up with a new equation, y equals x plus 1. Next, we substituted that value into the first equation, made it into one quadratic equation, and then we used factoring to solve that. We ended up with x values, which means we needed a y value since it's the system. Martin says to get the second equation, the smallest one, substitute both x values and give us the y values now. There they are. And what were those 2 points? Well, Clarissa said they are the intersection of both graphs. And thank you also, Brandon Felix, for reminding us on the warm-up. That is correct. Any system, the solution or solutions is where both graphs intersect. So with that said, if both graphs intersect at those points, let's plot those points in green on our coordinate plane. Let's do that, please. Negative 1, 0. Negative 1, 0 is here. Oh, let me switch to green. Negative 1, 0. And negative 4, negative 3. Negative 4, negative 3. So according to what we came up with algebraically, when we graph those 2 equations, they're going to intersect at these 2 points. Okay? So let's see if it's true. Look up. So we're switching now gears to graphing. Everybody with me? All right, so here we go. So we're going to rewrite these to graph. We're going to rewrite both equations, make sure they are solved for, make a note, solve for y, both equations. Both equations solve for y. And I'm going to write them over here. Which one's already solved for y, guys? The bottom one. So I'm going to write y equals x plus 1. So write that automatic there. How about the top one? What do we need to do to leave y by itself? Tell your neighbor, please, what do you do to leave y by itself on the first one? Yeah, Vianney, what do I do? To leave y by itself? Yeah, plus 6x plus 6x. So we end up with y equals x squared plus 6x plus 5. We there so far? Yes? All right, so to get started, let's graph the red one. Look up. Where do we start? At what? Positive 1. Plot your point at positive 1. There it is. Next, we need a slope. What is my slope for this one? What is the invisible number here? 1. In fraction form is 1 over 1. That means from here I go 1 up, 1 to the right, plot your point, do it again. 1 up, 1 to the right, plot your point, do it again. 1 up, 1 to the right, plot your point, do it again. Look up. Now if you want to go the opposite direction, look up. Where we started, instead of going 1 up, 1 to the right, we go 1 down, 1 to the left. 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 And sketch your line in red. What do you guys notice? Is that line going through the 2 points that we predicted where they're going to intersect? Hoo-wee! Let's go, David. All right. You're like, that's good and dandy, Mr. Q, but how are we going to graph the first one? Well, for the first one, look up. I'm going to zoom in, and then we're going to make a table for the first one. Ready? Here we go. See what I did there? Table? Yeah. Never mind. Anyways. Not that table. X, Y. That was a good one, right? Yeah. Tell your neighbor the domain we're going to use. What's the domain? Everyone? -2, -1, 0, 1, 2. All right. Let's see if with those values, but let's look up. Let's see, where are we at? Look up, guys. If we use -2, -1, 0, 1, and 2, will that graph show the intersection all the way over here? No. So what value should I use now? Negative. How about -3? How about -4? How about -5? So check this out. We're not going to use these. We'll use 0. So we're going to use from -5 all the way to 0, from -5 to 0. So make sure on your home plate you look at the graph when you get started. So -5 to 0. So I'm going to change the bottom 2 to -3, -4, -3, -4. All right. So let's write our equation. Y equals parentheses squared plus 6 parentheses plus 5. So what's my first value? My first value is -2. So y equals 4 minus 12 plus 5. So to save space, look up. What is 4 plus 5? 9 minus 12? -3. Write it in there. Let's do it again. Now for -1. Y equals parentheses squared plus 6 parentheses plus 5. My next value is -1. So y equals 1 minus 6 plus 5. What is 1 plus 5? 6 minus 6? 0. Next, now we substitute 0. So this is 0 plus 0 plus 5, and that is 5. Next, next value is negative 3. So we got y equals 9 minus 18 plus 5. What is 9 plus 5, everyone? 14 minus 18, negative 4. And the last but not least, y equals parentheses squared plus 6 parentheses plus 5. Let me move this up a bit. And my next value is negative 4. So y equals 16 minus 24 plus 5. What is 16 plus 5? 21 minus 24, that's negative 3. Yes? All right, let's plot those points. Let's see what it looks like. Let me zoom out. Negative 2, negative 3. Negative 2, negative 3. Negative 1, 0. 0, 5. Was it 0, 5? Yeah, 0, 5. Negative 3, negative 4. Negative 3, negative 4. And negative 4, negative 3. Let's connect those points from left to right. Ooh-wee. And in green, I want you to do this. Point here and point to there. And tell your neighbor what you're going to label that. What are you going to label this and that? What would we label that, Brandon Doherty? Yes, solutions. Why are those the solutions of the system? Tell your neighbor. Why are they the solutions? Jacob squared. Why are those the solutions? That is correct, because we wrote it over here. Solutions. Intersection of the graph. Ah, my goodness. So, from 1 to 5, how comfortable are you so far with these two methods? You got some 3s, 4s, 5s, 23s. I see that. Okay. So that means you need another one. Is that correct? All right. So, let's see. Yes. Check this out. Look up. Now, we're not going to do another one exactly like it. Look up. Which is very similar. This one's very similar. Write it down in your notes, please. We're not going to do that one, but write it down so you can do the practice on your own. Y minus 6 equals x squared plus 5x, and y minus 3 equals x. All right, set that aside. What I do want to get to is this one. Look up. So watch. I'm going to focus right now on graphing because we know how to solve this algebraically. For graphing, both of them need to be what? Equal to y. Is that correct? So look up. This top one, what do I need to do to make it equal to y? Tell your neighbor what we would do with this one. Yeah, plus 1 to both sides. So we end up with, parentheses, x minus 3 squared plus 1. This bottom one, what do I need to do to set it equal to y, everyone? Plus 2x plus 2x. So that means we end up with 2x minus 5. All right, so look up. Going to go pretty fast, so stay focused. I'm going to start with the top one this time. Now, look at it. What is the parent function of that one if I was to change this to g of x? What would be f of x? F of x equals what? X squared, is that correct? Which means it's what? 0, 0, 1, 1, 2, 4, negative 1, 1, negative 2, 4. It's right there. However, in blue, where am I going to move this according to that? Tell your neighbor. Where are we moving that one to? Anthony. D. Or what's my new vertex? What is it? 3, 1. That is correct. 3, 1. And these points will be here and here. And let's see, 1, 2, 3 there. 1, 2, 3 there. So there's my equation graph using transformations. Can I graph this one now? Yes, Mr. Q. Where do I start? Negative 5. What is my slope? 2 up, 1 to the right, 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 and my graph should look like that. What is this point and what is this point called? Tell your neighbor. What are those points called? Martin, what are these points called? Solutions. Why? That's where they intersect. That is correct. That's what I want to see tonight's home plate. Tonight's home plate, I gave you one of these so that you know how to graph it. So, hopefully, it all transferred there. Let me show you the home plate once more. Here goes. There they are. It's only 3 problems: solving algebraically and solving by graph. All right? We'll stop right there. Everybody got it? Yes? And once again, tutoring after school. Be there or be elsewhere. I'll stop the video here. Bye.